Hi everyone. My name is Denis. I work at mail.ru. I'm a director of engineering for email and cloud of mail.ru. By the way, do you see this presentation on the screen? I mean, is it okay? All right, because it's kind of a little bit not too bright. Okay, so today my talk will be about Tarantool. Tarantool is kind of a cornerstone of our infrastructure at email and at cloud. So, by the way, have you ever heard about Tarantool? A couple of people. So, great. So Tarantool is a database, actually. So this is our homegrown database that we developed at mail.ru, and like I will just tell you about why we developed this database and how it helps us to solve some problems. So when you probably first hear about a new database, then your first question is that how does this database differ from all others? Because there are more than 300 databases out there, and it is like 301st database. So it's always been a question about why do we need a new one? Let me explain this to you. In this picture, you can see that we can divide databases into like two more or less big groups. So one group is like old school reliable databases like MySQL, Oracle, Postgres, many more. Microsoft SQL Server maybe. So there are many databases. They're all almost all of them are SQL, so they're based on SQL language. And the main thing about those databases that are on the left side is that they are reliable, durable, so you can rely on them, so they will never lose your data. Plus, they have some features, like they have SQL language, they have some kind of sophisticated data structures, so like tables, indexes, secondary indexes, and many more. But they have only one problem. By the way, what is that problem about those databases? Scalability, maybe. And what else? Performance, right. So this is the main problem of this database, because they were invented like, I don't know, 20, 30 years ago, and they are not very good at the web scale, I mean, for the web scale applications. So because now we need I don't know, we need maybe 1,000 more throughput that we need from databases 20 or 30 years ago. But they're still kind of the same. And on the other hand, there are some new databases like Redis, Couchbase, Aerospike, maybe React, and some others. Have you ever heard about these databases on the right side? No? They're very popular at the web scale applications. And so the main thing about those databases is that they are fast. So they say that, hey, we don't that durable as those old ones. But we are fast. So I mean, you cannot rely on us, but you can cache data. Have you heard this term, cache? Raise your hands, those who know what that means, cache data. Okay, this is good. So when you cache data, then you don't store them like as an authoritative source of truth. You just store a copy of this data, and the kind of the original copy of this data stored somewhere else. So these solutions that are on the right side of the screen, they're good for caching. So they're not reliable, but they got them fast, like 10,000 faster than MySQL or Oracle. So this kind of a short list of some features of the left side databases, like of old school, MySQL and Oracle and many more. And this is, these are features of right side databases. So you see they're completely different. They're all about reliability, kind of some data structures, data languages. And new databases, they're all about speed. So Tarantool is the database that sits in the middle. I mean, a database that combines both kind of world of reliability and world of speed. So that is like the main, I would say, selling point of this database. Okay, so Tarantool. It combines like both worlds, like both world of reliability and world of speed. But the question is, why is it so important? I mean, is it important to have kind of one solution that combines both, that combines features from both worlds? Is it important? Guys, how do you think? I mean, do we need this database that combines two worlds in one solution? Do we need this? Why? So we have one database for one thing, another data. I don't know, we have Oracle to store something reliably. We have Redis or memcached. Have you heard about memcached? Some of you heard. So memcached is maybe the most popular cache for the web scale applications. So we can store things that we don't want to lose in Oracle. We can store things that we can lose in memcached, and that's it. I mean, why would we need a new database? So I mean, why is it so important to have both kind of features? So in fact, it is important. There are many applications, many cases when you need both, when you need like both features from both worlds. Here's like a short list of these applications. They're all about web scale. So for example, session management system. So just imagine if you have a huge portal, like with many millions users of daily audience, then you need to store session. You need to store sessions. Do you understand this term, sessions? What is that? Session. I mean, when you think about like an internet portal, like email service or whatever, what does that mean, session? So session is the thing that it is like a cookie. Have you heard this cookie term? No? Like in browser, you have cookies, okay? So session is a cookie that stores some unique piece of information that authenticates user when user uses a service. So I mean, every time a user, I don't know, clicks a page, then the browser passes to the server this cookie along with the request, and this helps to authenticate. So we need to check this cookie on every click to our website. And we need to do this fast, but we need to do this reliable, because we don't want to lose sessions. Because if we lose sessions, then all the users have to enter their login and passwords. That is like a bad thing for a big website. How many of you guys remember your password to your email service, for example, or to your Facebook? Nobody. Okay, half of you, right? So when when a service has a problem with session storage, then for those of you who don't know your passwords, you need to enter them again, but you don't know them. So this is very important. And the same thing about other applications. I mean, other web scale applications. Okay, so let's go next. I mean, this is not only about web scale, by the way, it's about enterprise scale also. You know, enterprise scale application is an application that works for like one company, like inside one company, like kind of internal system for employees of this company. And enterprise scale applications also have to be fast because, again, users don't want to wait. And again, they have to be reliable. So this is very, very common problem these days, that you need to have kind of a storage system, like a database, that is fast and that is reliable. So this is about Tarantool. But one question is, how can you make a system, like a database system, fast and reliable, like without Tarantool, but using only old building blocks, like old databases, kind of like MySQL, Oracle, and new databases like Redis, Memcached, and many more. The common way to do this is to build a cache on top of a database. So like you have a database, you have a cache, you put a cache on top of this database. Put a cache on top of the database means that, by the way, what does that mean? What does this construction mean? Put a cache on top of the database. This means that all the requests that go to this database, they're first handled by a cache layer. Like when you query a database, and if you have this information in a cache layer, then you answer to user immediately with that information. But if you don't, then you query a database. So this solution, well, it solves this problem partially. So I mean, so for example, you have some database features, but you lose some database features. Like for example, transactions. Do you know this term, transaction? Raise your hand who knows this term. And so what is that? What is transaction? Yeah. So transaction is one operation that is completed like everything or nothing. So it can be like many operations, but they're all completed all or not at all. So you lose this property, of course, because you have cache. So caches don't have transactions. And the same thing about other group of features, speed. So again, you lose some of them. So for example, you don't have that goddamn fast speed on update operations, because every update operation hits a database, and database is slow. Plus, you have some new problems like cold start or data inconsistency, because when you store information in two different sources, like in two different kind of, I don't know, storage systems, that data may be inconsistent between them. So that is why this solution is used, but it is not very good. And that is why we came up with this idea that we need to fix it somehow. So that is why we started to working on Tarantool. So the database that solves this problem, that is a database and a cache in one thing, like a database for a web scale, for web scale applications. Yeah. Now I just wanted to show you how we decide first to create Tarantool, to create a homegrown database. So first it first started with the cache. So we thought that, okay, so we have a cache, like memcached or any other cache. And we need this cache to be reliable as a database. So if you need something to be reliable, then you need persistent to this something. Persistence means that, what does that mean, persistence? Persistence. In the world of databases, persistence is what? Nobody knows. So persistence is ability to save information to disk or to some other means of storage that you can read from after a power outage. So I mean, when you store everything in memory, in RAM, then when your server reboots, then what? You store a database in memory, in RAM, then you reboot this machine, and then what? What happens? Hmm? Yeah, gone. Yeah, so you lose everything because, well, RAM is RAM, right? It's fast, but it is not durable. So you need to persist your data somewhere on disk. The most maybe how to say the simplest way to do this is to create snapshots of this cache, of this RAM, like once in a while, like, you know, write on disk, like every now and again. But the problem is that you need to persist every update. But snapshots, they happen on some schedule, but not all the time. So the next thing is transactional log. So when you have snapshots and transactional log, then your cache is a durable database from this point and on, because now you store everything on disk. Every transaction, every change that you do inside your database, inside your cache, you store here. So when your database reboots, then it reads all the data from here, from snapshot. Then it reads all the data from here, and then it applies all the transaction to memory. And then it is up and running, like it was before power outage. So you can restore the state of your database totally. And the next thing is various DB features that that every database should possess, like replication, like backups, server-side language, storage procedures, and many, many, many more. So as simple as that. Like a couple of words about our team. So our team is very simple. It's like a number of software engineers. We're doing everything in C, C++. It is kind of a C with a slight taste of ++. Are you using this language, C, C++? Okay, that's great. So this good old language is still very, very, very powerful and the most efficient. So we're using C, like I told you, with a slight taste of pluses because we need the maximum efficiency, you know, for our database. And Python, we're using Python for various scripting purposes, something that we're doing outside of the core engine of this database. And the last but not least slide is about our tasks that we are doing right now. I mean, maybe not today, but from the next week. So we're developing our database. It is still under massive development. So for example, we are doing cluster solution, cloud solution. We're doing many things about optimization, plus we're doing many things about migration from other databases, or we're doing interfaces of other databases, like SQL interface or Mongo interface. Have you ever heard about Mongo? MongoDB. Oh, that's good. It's the most popular NoSQL database in the world. By the way, have you heard this NoSQL? Like SQL and NoSQL. SQL, NoSQL. Have you heard these terms? No? So SQL is the language for databases. Structured query language. NoSQL, NoSQL is like not a language, but it's kind of a notion about new databases that don't have SQL, because they have something that is more efficient than SQL. So we are doing all of those things, plus benchmarking, of course, so a lot of benchmarking, because we're trying to compare ourselves with other databases. Okay, so that's it. Thank you for listening. And if you have any questions, I will be happy to answer them.